Hello guys, welcome back to Avijit's classroom. So today we are discussing about a linear algebra question. So let A be an n-cross-n matrix over a sets of real number. So A be a matrix of n-cross-n and let B be the matrix obtained from A swapping two rows. So B we can find that swapping two rows from A. So which of the following is true? So we have a four option. The determinant of B is negative of the determinant of A. If the A is invertible, then B is also invertible. If A is symmetric, then B is also symmetric. If the trace of A is 0, then the trace of B is also 0. So from that, so we can get that A is a set of real number. So and A is an n cross n matrices, and we can swapping out the two rows of A matrices, we get B matrices. So clearly we can say is the dimensions of A is also n cross n, and the dimensions of B is also n cross n, because we can find that we can swiping out the two rows from A, we get the B matrices. So from that, so sets of real numbers. So for that, we can get an example. So the determinant of B is negative of the determinant of A. So for example, if suppose we can say A is a 0 1, 1 0 0 1, is it true cos true determinant? So we can find that B is, so swapping out the two rows means 0 1 1 0. So determinant of A is, we can find the determinant of A is, what is, we can get 1 into 1 minus 0 into 0, so we can get 1. And determinant of B is 0 into 0 minus 1 into 1, so we can get minus 1. So clearly we can say that the determinant of B is negative of determinant A. So clearly we can say that the determinant of A is negative of determinant B, or we can say the vice versa, determinant of B is the negative of determinant A. So the option A is true. So now suppose we can get check the option B. So option B says that A is invertible, then B is also invertible. So invertible means, so A is invertible means that the determinant of A is not equal to 0. So clearly we can get the determinant of A is not equal to 0. So then we can say that then it is invertible. Then it is invertible. So if A is not equal to 0, and we can say the previously B is equal to minus of A, so B is equal to minus of A, and if A is not equal to 0, then we can say that B is also not equal to 0, also not equal to 0. B is also not equal to 0. So B is also, then B is also invertible. Only A and B relationship is negative. B is negative of A, determinant of B is negative of A, or A determinant of A is negative of B. Also A is invertible when B is also invertible. So option B is also true. Let's suppose check the option C. If A is symmetric, then B is also symmetric. So for symmetric, so let's suppose we can get A is equal to 1 to 2 3. So we can say that apart from the lyric number, all the elements are same. So if we get back the swapping the two rows, we get 2 3 1 2. So if A is symmetric, A is symmetric, but we can get that B is not equal to, not a symmetric matrix, not a symmetric. So option C is false. C is false, because if A is symmetric, B is not necessary that it is a symmetric. It is also a not symmetric. So now let's suppose option check. We can check the option D. So option D, that if the trace of A is 0, then the trace of B is also 0. So we can find that the trace of A is 0. So let's suppose take an example where the trace is equal to 0. Trace means the sum of the leading diagonal. So if we can say minus 1, if we can get minus 1 t, okay. So if we can get 1 minus 1 0 minus 1 minus 2 1 0 1 1. So this is a 3 cross 3 matrices, 3 cross 3 matrix. So the trace of A is trace of A is the sum of the leading diagonal. So 1 plus minus 2 plus 1. So we can get 0. The trace of A is 0, but we can find that, and it's swapping out the two rows we can get the B. So B is equal to swapping two rows means minus 1 minus 2 1 1 minus 1 0 0 1 1. So we can get the trace of B is minus 1 plus minus 1 plus 1. So we can get 1. So not necessary that the trace of A is equal to 0, then also B is equal to 0. So this is not is equal to 0. So this statement is also a false statement. So from the given questions, so the determinant of B is negative while the determinant of A. So this is also a true statement. If A is invertible, B is also invertible. This is also a true statement. If A is symmetric, B is also symmetric. This is false statement. We can say that B is not necessarily symmetric. If the trace of A is 0, then the trace of B is also 0. This is also not necessarily true. So this is also a false statement. So correct option of this question is A and B. Thanks for watching. If you need this type of content, please like, share, subscribe to our channel. Bye.